The idea behind this course is to give you some ideas as to how we go about forecasting weather. In order to do that, we're going to have to understand some various aspects of weather. We're going to talk about things like pressure, which you're looking at right here. This is a surface weather map with equal pressure lines analyzed. They show high, low pressures, and where the pressure gradient, which is the tightness of these isobars, is stronger. All these things. They even have temperatures on them. Uh, they show humidity, winds. This is a complete picture of what, if you walked outside right now, what the conditions should be like where you are. The idea is that we plot surface stations all at the same time on this weather map to depict weather. Weather is what's happening now. So let's look at some stuff you're going to be seeing this week in your course. So we're going to start at the beginning of this slideshow here, and I'm going to move along pretty quickly through it. So this whole week is what are some of the basic characteristics of the atmospheric weather. So in the past, there have been some monumental weather events, and weather has forecasting. What the forecast is has improved significantly over the last years and continues to improve, actually at a very rapid rate. So, weather is what's happening now. If you walked outside right now and I ask you what's the weather, you'd probably tell me, oh, the temperature, it's kind of cold, or kind of warm. It feels kind of muggy today. It's humid. Well, I'm looking up in the sky and wow, there's a cloud. So those are all aspects of weather. Meteorology is just the study of the weather. What causes these things? Why is today cloudy? Why is the temperature 78 degrees today instead of 32? Why is the wind blowing out of the south so strongly or not at all? That's what weather is all about. That's what we're going to talk about. Now, we're going to look a little bit at climate. Climate is an average of weather. In other words, if you looked at the weather over the last 30 years at your location, that's an average. How many times did the temperature go above freezing? When was the coldest day you had during that time? How much precipitation each year do you average? Their climate. And climatology is the study of climate. So if I want to know what the weather is now, I'm saying everything has to be exactly at the same time. So in other words, we have time zones around the earth. Currently, I'm in the Eastern time zone. Most of you probably are as well. I don't know where you're all located yet. I live in down here in the southeast corner of Virginia, which is the Eastern time zone. However, if I'm looking at that weather map I just showed you, I want all the weather to be exactly at this time. So that means that if I looked at 7 a.m. weather, then I'm looking at 6 a.m. Central, 5 a.m. Mountain, or 4 a.m. Pacific. And if I'm over in England, it's actually 5 hours different from here. Currently, my granddaughter is in Spain working on a course, and she's 6 hours different. So, all these different times, still, we need to take a look at everything at exactly the same time. So, no matter whether the clock is saying one time, I'm worried about what it is, as if we looked at the whole Earth as having just one time. So there are different types of weather systems. I just showed you quickly a weather map. You're going to be seeing so many weather maps, you're going to be very tired of them by the end of the course. Weather map consists of all surface observations. In other words, anytime there's somebody that takes an observation that the weather service can get a hold of, it's going to try to put that on the surface map. They're not everywhere. So we have things like cold fronts. All a cold front is cold air advancing and displacing warmer air. We have things like warm fronts. Same thing, except warm air is displacing colder air and moving that way. We could have a stationary front where you have warm and cold symbols next to each other. You'll notice cold has a triangle, warm has a semicircle. We have low pressures. Low pressure just means the atmospheric pressure is lower than the air around it. So at this center is the lowest of the pressure around this area. High pressure, pressure is highest. If you walked right into the center there, the highest air pressure would be right there. Well, as you walked away, it would change. And all these impact precipitation, temperature, winds, all things you're probably kind of interested in. In the northern hemisphere, high pressure winds, air flows clockwise around it, always. And low pressure, it goes counterclockwise. Get to know those. On a warm front, warm air is going to ride up over cold air, producing a large area of clouds. Matter of fact, as a warm front's approaching you, you may actually see high clouds first, then gradually lowering, finally brings in the rain. Cold fronts, typically much sharper, a lot stronger, change quicker, and the clouds tend to be very narrower, not cover as much of an area. Interestingly, fronts are three-dimensional. In other words, the atmosphere isn't just what's at the surface where you are. If you walked up a mountainside, the weather's changing as you go up. If you went up into higher in the atmosphere, it would be a different weather. We're basically looking, everything we're going to talk about in weather is in the troposphere. But that part is three-dimensional. So some fronts will have no clouds or precipitation. I had a cold front pass my house yesterday. Yesterday, temperatures at my house were 95 degrees. In the evening, one shower developed. The rest of the area around me was dry. I didn't get the rain. It didn't hit here. But that front went through. Today's high is in the mid-70s, and I have some clouds coming in off the Atlantic Ocean. And significantly different in humidity. It's much drier. So if I ask you to state what the weather is, and we're going to talk about weather like this as well, and I'm going to maybe ask you that in the discussion. One of the things I want to know anyways is what the maximum temperature is going to be today. In other words, I want to know how to dress. The same with the cold temperature at night or the dew point. Dew point's a measure of moisture. Relative humidity, how moist does it feel? Amount of precipitation. Hey, maybe I'm only going to get a couple drops of precipitation. Oh no, I want to get 3 inches of rain. Makes a big difference in what I'm going to do. Air pressure. It's the weight of air. We're going to talk a lot about that too. So we have satellites in orbit. Some of these satellites are geosynchronous. In other words, they stay over exactly the same spot. The National Weather Service maintains 2 geosynchronous satellites that monitor the U.S. One is centered near the equator over the Atlantic Ocean. One is centered near the equator over the Pacific Ocean. They have an excellent view of all of the United States. And they never change. Interestingly, we have polar orbiting, much lower, higher resolution in some ways, but they don't really, since they're not staying over the same spot, they can't record what's happening constantly like a geosynchronous satellite can. However, the Earth rotates underneath them, so they pass over the Earth usually 2 times in a day over the same general area. Here is a geosynchronous satellite image. You can see here we create enhancements. We change the color. Even though we could have this all as a gray shade, but we chose at a certain temperature to change that shade to a little bit more yellow and eventually into red. These are higher, colder cloud tops, more like showers or thunderstorms moving around. You can see a circular pattern out here. That's a low pressure system because clouds tend to be around low pressure. So these kind of images we're going to talk about a lot. They really show you a lot of things. We love I love to watch clouds. The clouds can tell you a lot about what's going to happen in the weather in the future. We're going to learn how clouds form, why they form, and what they may portend for the weather in the future. Fog is just a different type of cloud. Uh, there are stratus clouds. Stratus clouds are kind of flat, stratiform clouds. You'll see them in a sheet. It looks like the whole area is just one little thick layer of clouds. Cumuliform clouds are kind of puffy. They look like big balls in the sky. We see them a lot in the summertime. And they can grow up into big thunderstorms, which look really, really large clouds into the sky, maybe going upwards of 10 miles into the atmosphere. And then we have some things called cirrus clouds and all that work in here. And we have clouds moving in different directions. When you look outside, many times you might say, oh, those real high up clouds look like they're moving one way, and those lower ones look like they're moving another. Well, the air moves in different directions in different parts of the atmosphere. So, all of this is what we're getting into in this course. This gives you a big, broad overview of how we look at the weather. We get observations from different airports. We get observations from planes that are flying at different elevations. So we're getting a three-dimensional picture. We may take a radio sound observation that looks up through the atmosphere. All of these are going to be talked about, and we're going to try to understand what is happening so you can see if you can forecast what the next day's weather is going to be. So I hope you enjoy it, and please, if you have any questions, don't hesitate to ask.